Okay, so the main topic of this lecture is open world reasoning. Okay, so the open world reasoning basically, I mean, there's opposite is of course a closed world reasoning, and I guess you guys probably took the database class, right? Basic database class, and pretty much your programming language and like any database, their assumption is based on closed world assumptions. Okay. So the CWA, the closed world assumptions, basically, if you use a CWA, you assume that everything that is currently known about the system is already in the database, right? However, in the OWL, right, was meant to be a language to bring semantic to the internet. So the language designers chose the OWL, meaning that we cannot assume something does not exist, right? Just because it is not currently in the ontology. Okay, so that's the definition of the CWA. I mean the OWA. Okay, so now, so we cannot conclude some information does not exist unless it is explicitly stated that it does not exist. In other words, because something has not been stated to be true, it cannot be assumed to be false. Okay, it is assumed that the knowledge just has not been added to the knowledge base. Okay, so that's the OWA, right? Maybe I should give you one example, right? Like let's say you use a database, right? The database you have an employees database, right? Or maybe you have a people database. The people database, you have a name, right? And then you have a job, right? And then age and etc., right? So let's say name is Kevin. And then somehow in the job, in the column is empty, right? There's nothing here. So if this is in your database, we assume that Kevin does not have a job, right? Because there's nothing, it does not exist, that means it's a false. So Kevin does not have a job, right? So that's the closed world assumption. I mean, this is a typical assumptions, right? But in the open world assumptions, right? When you see a blank, we cannot say whether Kevin has a job or not, right? Because maybe, maybe this information will be added later on, right? So when you use OWA, open world assumptions, your answer is, I don't know. I mean, maybe Kevin has a job, right? Or maybe, maybe tomorrow he'll have a new job, so this information will be filled later on, right? Or maybe even though the Kevin has a job, the system has not found his job yet. Okay, I mean it can be so in OWA, right? You cannot conclude that Kevin doesn't have a job. Basically, it's a question mark. So unless we explicitly say that, hey, Kevin has like no job, okay? If we explicitly state this, then yes, then we can say that we can conclude that Kevin doesn't have any job. But otherwise, when there is a blank space like this, we cannot really conclude anything because maybe his job will be added later on, right? So that's like open world assumptions. Now, having said that, right, let's just go back to our example. When you look at our example, if you look at the definitions of the vegetarian pizza, this is a necessary and sufficient conditions. And they are, it has to be pizza, and at the same time, this pizza can only have what? Cheese or the vegetable topping, right? These are the necessary and sufficient conditions. But now, when you look at the Soho pizza, right, and then Margherita pizza, if you look at this, for example, like Margherita pizza, it has cheese topping and it has vegetable topping, right? And then if you look at the Soho pizza and the mozzarella, which is cheese topping, olive, which is vegetable topping, the Parmesan, that it is what? The the cheese topping and vegetable topping, right? So it seems, right? It seems that what? This Margherita and Soho pizza should be what? The vegetarian pizza, right? According to the definitions. But when you look at this, when you look at the margarita and soul pizza, right? For example, like soul pizza, it says it's a cheesy pizza, right? Because if you look at the definition of the cheesy pizza, it must have at least cheese topping, right? So it's satisfied, so it's classified as a cheesy pizza. And then margarita pizza, the same thing. It's classified as a cheesy pizza because it has one cheese topping, right? But does not really say anything about the vegetarian pizza, right? So it should, since it should something like, you expect to see something like what? Vegetable pizza, right? But you don't see this. Why? Why? Because it has cheese topping and it has the vegetable topping, right? So it seems that it satisfies the definition of the vegetarian pizza, right? But you don't really see this. Okay, what is the reason? Why? Okay, because of what? Because of the open world assumptions. Okay, because when you just read this, we have stated that margarita pizza has a topping that are kind of mozzarella topping, also is kind of tomato topping. Because of the open world assumptions, until we explicitly say that margarita pizza has only this kind of topping, it is assumed by the reasoner that what? This is important. It is assumed that by the reasoner that margarita pizza could have other toppings. Okay, so this is what? This is open world assumptions. So because of the open world assumptions, we can assume that even though we did not really say it here, reasoners, the prototype reasoner, like a palate reasoner, assume that it could have what? Meat pizza, meat topping. It could have seafood topping, right? So that's why it's not as classified as a vegetable pizza. Okay, so because of the open world assumptions, the palate reasoner can assume that it could have what? Meat topping. It could have what? A seafood topping, right? Okay, so we have to explicitly say that, if you want the margarita or the soul pizza, if you want both pizza to be the vegetarian pizza, we have to specifically say that what? Let's say, for example, the margarita pizza can have only what? Mozzarella and, only have what? Cheese or vegetable topping only. Okay? So that's the important. So you know that it's, so to specify explicit that margarita pizza has a topping that are kinds of mozzarella topping and kinds of tomato topping, right? We must add what is known as closure axiom on the has topping property. Okay, so this is important. Okay, so closure axiom, right? So let's just go to the next page. So the closure axiom on a property consists of universal restrictions. So this is very important. It's universal restrictions, right? And then it says that the property can only be filled by specific fillers, which is what in our case is vegetable topping and what? Or the cheese topping. Okay, so the restriction has a filler that is a union of the fillers that occur in the existential restriction for the property. Let's see. Okay, so what we are going to do is we are going to add closure axiom on the has topping property for the margarita pizza and the soul pizza. Okay, make sure that so that these two pizza now what becomes classified as vegetarian pizza, right? So okay, so just go to the margarita. So I'm doing the exercise 23 and go to the margarita pizza, right? And then what? I'm going to maybe I'm going to just remove and then remove, right? And still is a named pizza, right? And then what I'm going to do is I'm going to add this closure axiom on a property consists of universal restrictions, right? That's what I'm going to do. So let's see, has topping, right? Only, and then mozzarella topping, which is cheese topping, right? Or tomato topping, which is a vegetable topping. Okay, so now I said okay. Now this is the closure axiom on a property, which consists of universal restrictions, right? Because it has only. So now when I run the reasoner, right? Let's just synchronize the reasoner. Now you see that now it's a vegetarian pizza, okay? Because it only has what? Cheese topping or the vegetable topping, which is the definition of the vegetarian topping, okay? Now for the soul pizza, same thing. What I'm going to do is I'm going to add this one has only, okay, so mozzarella, olive, and so I have to first get rid of this, right? And then subclass of has topping only, but this time is not the mozzarella topping. Let's see what are they? Oh, mozzarella. Yes. Oops. Mozzarella topping, right? Or the tomato topping, or the Parmesan topping, or olive topping. Right? Okay. And you know that it's all, they are all either what? Vegetable or the cheese topping, right? So it should be classified as the vegetarian pizza, right? Okay, so now let's just run. Okay, now as you can see, now it's what? It's classified as the vegetarian pizza, right? And think about it. Why now? Okay, think about it. Like both Soho pizza and Margarita pizza, right? It suddenly is no longer is part of the cheese pizza, right? And think about why. Okay. Okay. Now, yes. So let's see. Now let's just. I think it's next is just click this on the icon next to this inference to see the explanation generated by the reasoner. Okay, it'll be interesting. It's educational, right? Okay, so hold on. Okay, now, so hold on. Let's see. Okay, so let's see. This is a vegetarian pizza, right? Okay, so this is. Just read this, right? And this is. How the reasoner think about this. The Soho pizza and why the Soho pizza is classified as the vegetarian pizza, right? Okay, so if you just look at this briefly, you know that it's mozzarella topping is cheese topping, and the Parmesan topping is cheese topping. The tomato topping is vegetable topping. You know the olive topping is vegetable topping. So the vegetarian pizza is equivalent to pizza, and all have either cheese or the vegetable topping, right? So this is how they come up with this classification. Like the Soho pizza is what? A vegetarian pizza, right? It's a cheese pizza, and it's a vegetable pizza, right? And you know that it's mozzarella is cheese, Parmesan is cheese, and etc. Right? I mean, this is just interesting to read about, the message generated by the reasoner. Okay. So okay, thank you. I'm done with the exercise. Exercise 23. Okay, thank you.